Hello and welcome back to timer 8, I believe. Yes. Oh, timer 7. Sorry. Timer 7 of To Make It Go. So, in the last episode, I got a little bit mad because I was refactoring and I broke my tests, which means I wasn't refactoring, I was just changing some shit. So, I broke one of the rules of refactoring. So, I got a little bit mad and I ended the stream a bit abruptly. I apologize for that. And I went over and looked at what I was doing. So, the reason my tests are failing right now is because of this method right here. So I don't actually care about the identifier being present on the method, because I already know that that's true. I want the class of the object that I got from invoke. So I want invoke second class. I'm safe doing that here because if it was null, I would have gone in here. And we have to create that method. Then we have to say set is present dot class, which is what it used to be, and there we go. All of my tests pass again, and I don't. There we go. And that is what made me mad. Okay, there we go. Now we are now walking objects. So at this point, there is one other data type that I need to walk, and that is a collection. Or more specifically, a list. I believe a list is the only collection I'm going to accept. The reason for that is, well, I guess I could accept collection. Because a set is perfectly valid to iterate over. Because all I'm going to do is iterate over it and basically announce that it's a primitive. Or what have you, or an object if it has one. So it's either going to be, all I'm going to have to do is call, okay, walk object or walk primitive. Of course, respectively. And since generics go away at runtime, I'm going to have to pull that information up off the objects that I'm rendering as I go. So it should be quite an exciting adventure. So now, let's go build an annotated, an annotated object with a list in it. We're going to do the same thing we did last time as we did before. I'm just going to actually steal all of this because I don't particularly wish to type anymore. I don't particularly think you wish to watch me type anymore. Although, at this point, it might be the most interesting thing I'm doing. Because you watching me with spelling may become a drinking game of some sort, but that's beside the point. Okay, so this is object with a collection. Might as well handle the most generic. Identifier. Collection. We are going to make it return a collection. It's going to be a collection of object because it doesn't matter what's in there. I am going to return objects. I'm going to make that a field. I'm going to make it final and instantiate it in the constructor. The final keyword, just let me get that cool shortcut and doesn't matter, and I'm never going to change it. And I did it up here with this guy. There we go. Moving on. So now, we need to announce that we're entering a method. So we're gonna behave exactly like we did before. We're gonna enter a method, and then we're going to enter a list. I don't think that I'm going to provide any information other than I'm entering a collection, because the reason I'm going to announce that I'm entering the collection is because in JSON I have to put square braces around it. And the collection won't have an inner name or anything like that, so we don't need the name, we just need to know that I am in one. Okay. Yeah. That's what I think I'm going to do. So we're going to this dude, we're going to go to this guy. He's going to get a void enter collection. Oh, that was not collection. He's going to get an exit collection. We shall implement them. Entries. Dot add. Enter collection. Exit collection. We're going to create our same helper methods. Now that I think about it, I could actually just put the testing capability in this object. And then just walk, I walk down it? No, that'd be a bit weird, be mixing my spy with my, my tests, and it feels a bit gross. So I'm not going to do it. Okay. Private static. I actually need the certs. We're gonna have enter and exit. These guys. It strikes me that I could put all like this in an enum, and then enter type. Well, yeah. No, because we take multiple ones. Nope. It's just gonna look like that for now. Forever. We don't need that nonsense. We don't need that nonsense. That nonsense. That nonsense. That nonsense. And you are exit. We need a test. Test object with a collection. Grab all this. Collection object, collection. Yeah, null would be the most degenerate case. With a null collection. And in this case, I would expect collection object. Collection object, collection object. We're going to enter that method. We're going to enter that method. Tote that barge. And it's going to be a null, and it's going to be of type collection. Does do it. It should right now. Unable to walk requires an HTTP response code on the class. Okay, I agree. If it is a valid object, it would. A little bit disappointed that I didn't quite see that, but okay. Already, I've made the tests too unreadable. Okay, there we go. Okay, so that worked with no specific collection handling ability. So we're going to grab this collection with single item, single primitive item. It's a primitive. 1. Well, okay, we'll make it a singleton. You can win IntelliJ. We'll add an import for that. Singleton list. One object. So at this point, I would expect it to enter method. Well, now then, now that I think about it, well, what was the behavior for null objects? Yeah, so that's matching the behavior of null objects. I don't say I'm entering an object, I'm entering a primitive, and I go on with my day. Which, in some cases, may mean that so it'll be like list empty. Or in XML, it would just be an empty node. Yeah. Yeah. Now then, enter collection, enter thing. We will receive a 1, and I would expect that to be integer. That class. So it's going to get cast to an uppercase I integer because I put it in an array of objects, and you can't put primitives into collections in Java. So now then, with that in mind, this test will fail. Or at least I really hope it fails. Bada bing! It failed! What does we need to do to detect that? Okay. Ooh. Let's invert this if. So if it's not null, and the identifier is present, if that, else, we walk it as a primitive. Else if invoke is not null, and invoke.getClass is assignable from collection. Collection. So if it's a collection, it's okay. There we go. Well, now we got a value enter collection, so let's enter collection. Do I make it further in my tests? Let us find out on the next venture. We failed, which is to be expected. We still fail. So at this point, invoke does not equal null. Gotten up here, so which means it was null, or actually think. Okay, let's go back and look at that sucker. Wait, first, let's see if flip that. I get confused at times. Is assignable from confuses me a lot. Enter method. Expected is, but was exit method collection. Okay, that's where I wanted to go. Collection is assignable from the thing. Yeah, it means I can shove this guy into collection. So, listener dot exit collection. And at that point, that means I can perform this handy dandy cast. Collection of object from, well, objects equals invoke. It's going to tell me it's an unchecked cast, but it isn't really because I had a check up here. Yeah. Which means I'm going to come up here and suppress a warning. Look, I'm going to use the I know what I'm doing annotations. Or at least the please don't yell at me annotations. So at this point, we're going to be able to iterate over that. Now let's just enter primitive on that sucker. Whoa. I don't know what key combinations I was. Oh, calm. Object class. That will potentially cause a problem later, but we'll write a test to check to see what happens on nulls. There we go. Look at that, my tests pass. Okay. Let's single primitive, single null item. Put a null in there. Okay, at this point, this is going to be null. What class would I expect from a null? So I don't have any type information off of the collection. Do I have void? Ah, yeah, we're using void.class. That worked. Yeah, that didn't make any sense at all. Good. Well, it's just a type. Should use the. I'm going to use the void. Yeah, that's an object. That's a thing you. What does it say? Oh, it's got a private constructor. I can't make voids and hand them around. Your list of voids is coming. I'm not sure why I wanted to do that. That makes sense. So now, object equals null. Void.class. Colon. So if we have a null object, it's a void, and I'm going to put null in there, and we grab the class. I have made my decision. That way we'll also have class. Okay. There we go. It's a little bit gross that I chose to do that. Well, I needed a flag. I didn't want to pass null because I don't like handing nulls, and that's a class. It has properties. That will be fine for now. At some point I would Java doc that to let the next guy know what's going down. Well, it's actually documented in my test as well, so the next guy should know what's happening. There we go. Now, we need a single object. Yeah, so that's what do we do if there's an object in my array? Single object. We will make that the same as this nested class we used up here. So enter collection. At this point, we would enter the collection. We would assert enter object. Actually, we can just go steal that because it would be this exact same test up here. I would expect everything from this point on. There we go. And it didn't do it. That's a shame. Okay. Now we need an if statement here. Probably an else statement. We need to check that exact thing. enter primitive. Enter object, but instead of invoke, it is object. There we go. That should make my test pass. That did not make my test pass. Ah, object stack class. There we go. There is one more condition, a collection of collections, which I should handle. Because sure, you could put a list in a list. Which is going to be the exact same set of logic that I have now. Then I have to have a collection of collections of collections. I'm sensing a recursive call coming. Yeah. Yes, I am. Or you can say I don't support that, and you can go bugger off. But that's probably not fair. So, do I want to do it? I don't ever know. Well, yes, it would be helpful if I needed to like display a 2D array, but at the same time, you could just do the trick with a single-dimensional array. There's some maths to perform, but no, for convenience sake, I should handle arrays of arrays. So, that means, oh, my test passed. I can do some refactoring. So I performed this logic here and here, which means I can say is safe or is a walkable object. So is a walkable object, we walk the object. It's a walkable object, we walk the object. For everything in there, it's a walkable object. Yeah. Now I can also do this. Walk collection. Test. All my tests should pass. I just extracted a method. That's neat, nice and straightforward. So if it's a walkable object, we walk the object. Is walkable collection. We walk the collection. Have a cast. So now then, hide that from myself. So for each method, we get the identifier value, we invoke the method, we enter the method. If it is walkable, we walk, or if it is a walkable object, we walk the object. Else, if it is a walkable collection, we walk the collection. Else, we treat it as a primitive, and we notify the observer, and then we exit the method. That's fairly straightforward. Except at this point, well, my tests pass. There we go. It's still pretty big for a method. But I don't know that there's much I can do about that. Okay. And now this dude, walk collection, we enter the collection, we exit the collection. We don't need that. We can call this objects. If it's walkable, we walk it, otherwise it's printer. Now we need to reproduce this chunk of logic up here. Which I think I could boil down to something as simple as handle object, handle method result, enter method, handle method, exit method. And I think that code's going to be identical to this code. Well, let's find out. And then, okay. A single collection. So now you get array. Oh, it's singleton list. Singleton list. Singleton list of 1. So enter collection. We would expect another enter collection. We would expect another exit collection. We won't have this. We won't have any of that. We will just have enter primitive integer 1. But no, it printed out the toString value. Okay. So now to fix that, we would say else if is walkable collection object walk collection object. With a cast. So we have to have it, well, if it passes, I'll have another suppress warning on checked cast. But it didn't work. Where did you fail? Sorry, the recursion was a bit too strong with me. And integer dot class, because it's uppercase I in this case because it is in a collection. And it's 1, not 0, because it's definitely not a Q. It could be a Q. There we go. Ta-da! I am now, do all my tests pass? I now can walk an annotated object with walking collections, objects, and everything else in between. So if you notice, this logic is the same as this logic, which means I should be able to method invoke. Nope, I don't have a method. It's not the same. Because this guy's return type is different. Okay, so it's different logic. Almost different logic. But no. That needs to stay the same because I don't have that type of permission. There we go. So now, in my next episode, I will get to show you how to build the guy that renders the JSON. So, that was Alexa, if you did heard it. It got mad at me, and now it's going to yell at me some more because I said the keyword. Okay. Okay. Which means I'm probably mush-mouthing at you, or anyone out there. There we go. What is that? 200 lines? 150 lines. And I can take this interface out of there. These are one-line helper methods, which is fine. Some exceptions. There we go. Ah, right. I was going to suppress a warning. Unchecked. Because it is an unchecked cast. Here we go. I have 2 unchecked casts. Woohoo! Now then, the goal. Well, I could technically actually make that the same as this. strictly speaking, it would be fine. But no, and then I don't know that it's worth it. Well, I would. Okay. I don't think so. Okay, there we go. That is me walking my object, and my time is up. So in the next episode of To Make It Go, we will implement a listener that renders out JSON. Well, I don't know that I'll fully implement it in a half an hour. That may take a bit more work because I will have to be dealing with a stack, and that's a bit much to do in a little bit. There we go. Nice simple method. It's relatively small. Some people may claim it's too big, and I'm not particularly sure how I feel about streaming a recursive method call inside of streams. That might be heavy, but I'm in Java. I don't get optimized recursion anyways, so that's definitely not tail optimizable. But the other option would be to convert it into, let's list our queue for depth first recursion. And walk it that way. Keeping my current context as I go. No, stack, sorry. Stack. Keep it in a stack. Push. Go back to my context. Context option, walk and stack. Same could do with collection. But my tests are finishing in milliseconds, so I don't know that I need that. But I haven't tested large depths. So right now, this is fragile when it comes to our deep objects. Also, at the moment, I am susceptible to an infinite loop. I get stuck in it. Nothing's preventing infinite loops, other than the stack exploding. There we go. That is my annotated response walker. It walks the objects where the annotations are. And that is the conclusion of this wonderful episode. Thank you for tuning in. And I'm going to sign off for now.